2 of these things. Square root of 50 we did already. Woohoo! Now this one's interesting. I see people do this in a couple steps, which is perfectly fine. For 72, you could say it's. Say it one more time. 6 times 7 is 42.
Oh.
Yeah. 72, 8 times 9, I like it. Right? So it'd be the square root of 9 times the square root of 8. The square root of 9 is 3. But what's up with 8? 8's got still a piece in it that you can do something with. Right, so you can break this up as square root of 4, square root of 2. Square root of 4 is, times 3 is 6. And whenever you do that, you can go back and go, oh, I could have done this like this. 36 times 2 is 72. Square root of 36 is 6. Square root of 2 is, I don't know. I like it. You guys all right? Okay. I like having people like this. Yeah, I'm fine. What? Why's your face up there? Square root of 120. My face there. So what do you guys break this up as? Oh, okay. So a lot of you guys, all right, let's do this one the other way. So 12 times 10. Okay, 6 times 2 and 2 times 5. So this is 3 times 2 times 2 times 2 times 5. If you want to do it this way, it's fine. So what do you see 2 of? And what do I say 2 of? What is it that tells me I'm looking for groups of 2? The fact that it's a square root. If it was a cube root, I would have taken all these out as 1. But I need groups of 2, so I put a 2 out front, square root, and what's left inside? 30. And if you realize 120 is 4 times 30, square root of 4 is 2, square root of 30, I don't know. That's how the other way would have worked. This is another one I did. Alright. I think it was before that. Didn't I do this one? Yeah. It was 16 times 5, so 4 at 5, check. Good job, John. 5 was one that you can't do shit. 33 is 3 times 11, it ain't going nowhere. So it's just not, you can't do it. It's already simplified, or can't be done, or whatever you want to say there. Don't just leave it blank, because then I assume you didn't know what to do. Maybe. Something, write something, like already done, or something. Yeah.
Would it be wrong if I put 11 root 3?
Why is that wrong? The only way a square root works, what did we do here? What did we put out? A 2. Why was I able to put a 2 there? Because there were 2 of them. I have 1 3 and 1 11. The square root requires 2 of something. Yeah. Does that make sense? So that's another reason why I don't like this way, is because the language I have to use, a 2 comes out. That is not what happens. Why is there a 3 here? Because the square root of 9 is 3. A 3 didn't come out because that's not allowed. You can't take something out of a root. Anyway. So why do you share that way, Jeff? Because it works, and there's a lot of people like it. Let me see, 6. That was the one that hopefully some of you guys saw. It was just a straight up something you're supposed to know. Cube of 64 is 4. So I put some on here that didn't work, and I put some on here that worked really good, just to remind you that just when we learn something new, it doesn't make everything become that thing. Right? This guy. Okay, so you can start off with 4 times 10. 2 times 2 times 2 times 5. You're looking for groups of 3. So what do you write out front? 2. And what's still in a cube root? Keep it a cube root. 5. That's fine. The other way would have been, this is cube root of 8 times cube root of 5. Cube root of 8 is 2. Done already. Sorry, I keep pushing you that way. Look how long that took. No, sorry. Nothing wrong with this.
I think it's just because I'm not comfortable with my square and cube roots.
But see, that's why I like to push you in this direction, because you have to become more comfortable with this. You can have a list sitting next to you. 1 squared is 1, 2 squared is 4, 1 cubed is 1, 2 cubed is 8, and all the way down, and just have it to check as you're doing these problems. Get them in your head. Oh, let's see, 8. Let's see if we can do this. I'm going to force you guys to do it the other way. So what do I try? I try 8. 8 doesn't go into 54. What's the next cube up from 8? 2 cubed is 8. 3 cubed is 27. 2 3s is 9. I need 3 because it's a cube. 27 goes into 54. Yes. 27 times 2. So it's a cube root of 27 times the cube root of 2. Cube root of 27 is 3. Cube root of 2 is? I don't know. Now, if you did it the other way, yes, this is 9 times 6, right? 9 is 3 times 3. 6 is 3 times 2. You see 3 3s. You're looking for groups of 3, so you put a 3 out there. What's left behind? Poor little 2 all by himself. Left inside. Everybody is everybody's looking at me like, is somebody coming through the wall over here? Oh yeah, it's the clock. Oh yeah. This is a very lucky number here. 888. And it's in your face. What number are you going to divide by? Freaking 8. Why 8? Because it's a cube root, and 8 is a cube rootable number.
I was stretching. I was going because I was thinking
Thinking
that
ahead.
the cube root of 8 is 2.
I'm with you. Don't worry. So I got the cube root of 8 times the cube root of 111. Cube root of 8 is 2. Now think about 111 for a second. Who thinks 111 is prime? Who thinks 111 is not prime? Who doesn't like to raise their hand? There you go, that's fine. It's like, okay, that's weird. Why is 111 definitely not prime? Because 1 plus 1 plus 1 is 3. So 3 will go in. That seems really freaky, but I know 3 will go in. 3 goes into it how many times? 37. And 3 and 37, that's not going to go anywhere, so I can stop. You got to be careful. Don't just stop because you're like, I don't think that works. Take a second, you got to think about it. Does something else go in? Can I break it down again? No, in this case you can't. And then the 10th one, what's wrong with this guy? Poor little dude. 100 is made up of only 2 10s, right? And they each have a 2 and a 5. So there's not 3 of anything. It's missing like 1 more 10 to be able to be done. So that's another one that's just like they're already simplified or they can't be done or whatever. Already simplified, blah, blah, blah. All right. Last thing for today. You guys are freaking me out. I'm thinking somebody's coming. Try not to make any Game of Thrones jokes. Anybody didn't see that last episode?
If they ever watch it, it's
Oh, sure. You better not start doing that shit, because sometimes I fall behind. You don't want to piss your teacher off. Okay, so now watch this. This is the immediate next thing we can do. So some of you guys, I'm sure, are sitting there going, that's great. That's really great, Jeff. Good job. We rewrote this shit. Yay. Right? And even after I do the next thing, some of you guys are going to still say that, but oh well, I can only do so much. But tell me this. What do you? Let me build up this a little bit. What do you think? Actually, let me do it this way. What the hell is x plus x? Just what's x plus x? If anybody says square, I don't know what it is. 2x, right? What about m plus m? That's amazing. What about square root of 7 plus square root of 7? Darn it. So
2 square roots of 7.
2 square root of 7. What are roots based on? Roots are written as fractional powers. So what are roots based on? Multiplication. What will they not play well with then? Addition, subtraction. But the same way, I don't know what the hell that is, but there's another one of them. So there's 2 of them now, right? I don't know what that is. There's another one. I don't know what square root of 7. Do you know what square root of 7 is? No. But there's another one, so now there's 2 of them. You got to be really careful to not let this look like this, right? That's the square root. You shouldn't even write the 2, but that's 2 times the square root of 7. Be really careful about that. Okay, so that's nice, right? What about this? What's 5 square root of 11 plus 2 square root of 5 minus 6 square root of 11? What are your like terms?
Square root of 11.
I got 5 things minus 6 of those same things, so how many of those things? -1 of those things. And then I got this guy, just all by himself. No more roots of 5. Poor little dude. Do you see how, watch. What's 5x plus 2y minus 6x? Same problem. It would be 2y minus x, right? 2 of those things minus 1 of those other things. So this isn't really an unknown, but in some sense it is. Square root of 7 is a number. I could figure out what the approximation is, put it in my calculator. But do you know what it is exactly? No. So in that case, it is an unknown. It's going to work like any other unknown. You can combine them with other unknowns. Collect how much unknown shit you got going on. Okay, maybe. So here it is. Here's this. How this stuff comes into play with this stuff. So the fact that radicals are unknowns in a way, but they're not really. They are numbers. I can do shit with them that I can't do with x, for example. So look at this. You can do it, Jeff. Let's not start with that. All right, calm down. Let's do square root of 50 plus square root of 18. Okay, you've got to get over saying this is square root of 68. That makes no sense. None. It's like saying 1/2 plus 1/7 is 2/9. What? No. You can't say that's square root of 68. That makes no sense. All right, Jeff, so what the shit do we do then? Well, I can do something with square root of 50, can't I? So they're currently not like terms, but maybe I can uncover like terms. Square root of 50 is square root of 25 and square root of 2. Square root of 18 is?
9.
Yes. Do you see how they're both going to have that left? So I got 5 roots of 2 plus 3 roots of 2. 8 roots of 2. So I can do a little more. They're not really variables, but they are unknown on some level. But if I don't have any like terms, maybe I can reduce them and get like terms. Can't do that with x and y. Now, to be honest, what we just did was we kind of jumped over section 10.4. Yeah, because 10.5 comes right off of 10.3. So if I wrote this book, I would have put it in the right order. We will come back and talk about 10.4. Not surprisingly, 10.4 is dividing radicals, because we just talked about multiplying them. So then we got to talk about dividing them. I like it. But I think that's enough. Let's stop there. Is that all right? Okay. So tomorrow we'll talk about when the next quiz is going to happen and what it's going to cover. But I haven't thought about it yet.